reason to try to do a census because you've got other things to do like spend time with your family. So, go ahead, Katie.
What 4 were you talking about? You said 4. I saw the 50%.
Oh, this 4% right here.
Okay, 4 plus or minus.
Yeah, 4 plus or minus. It has to be applied.
Is that the margin? That's the margin of error.
Yep, and it always tells you in the poll what it is.
Okay.
It'll always tell you in the poll what it is. You have to look for it really hard sometimes. Sometimes it's in 2-point font, 3 pages later, but it is in there. They'll always tell you your sampling methodology, and you'll see that on the quiz for next week. All right. Let's take the rest of today, now that we have a working knowledge of a few terms, and let's understand, once you have this beautiful sample data, how you should throw it out to the world to see. I'm not saying that you're always going to do inference. You just did some good inference on that Gallup poll, yes? By putting the margin of error on there. You don't always need a margin of error. Suppose you only have 20 people that work for you, and you want to keep track of how they're doing in their job. You don't need a margin of error. You got 20 people. Go count them all, yeah? There's nothing wrong with doing that. There's nothing hard about doing that. But suppose you hire a statistician to do it anyway. It's amazing how much work you can get as a statistician. It is incredible how much work you can get as a statistician. I can't sit in a cubicle all day long, or I go do it myself. But it's amazing. People just they shy away from stats. So here's some numbers. Products made in a week. Statistician collects them and says, here we go. You're done, Mr. or Mrs. whatever. Here's your results. And they hand them back this. This is raw data. Beautiful, raw. Everything's there. You know exactly what you're not tied to an employee with this data. You're not correlating. Somebody said correlation or a scatter plot earlier today, I think. Maybe I said that. So you're not correlating with the employees, but at least you know how many products were made in that given week by summing them all up. Okay. So if you were the employer that paid the statistician thousands of dollars to do this, how would you feel about getting these numbers handed to you? I'll accept many answers right now. Please, Sandra.
Add them up and then divide them by the amount.
What would that give you?
That'd give me an average.
You get an average number, so in other words, you'd be happy because now you can calculate an average workforce. Should you use an average, do you think?
Should I use an average?
Yeah, because an average is an easy number to calculate, but should we always use it? This is a loaded question you don't know the answer to yet.
Not necessarily.
Not necessarily. Maybe. It depends on some conditions, which we're going to learn starting on Tuesday, I promise you there.
Right. Okay.
But that's one thing you could do. Add those up, divide by 20. That's the average number of products made. Eric, go.
I'd really like to see it sorted.
I would really like to see it sorted as a vote. So in other words, raw data is fantastic. But why sorting it, Eric?
I think that the organization, and you can kind of see midpoints, you can see more about the data now.
Okay, maybe even helping pairing off with what Sandra's saying. I like this. Rachel, go. Oh, listen to this. These phrases, I love this. I love this. So I'm hearing sorting because this data is unsorted raw data. I like unsorted raw data. I mean, you got it all there. But sorting the data helps us see underlying patterns. Here's one way you can do it. Here's one way you can, and remember, this is all, you're going to have this online to download, right? All this stuff is yours to download. Number of products column. Somebody called this a T-table yesterday in 243. I thought it was great. Tie it back to like Math 60. T-table. I love it. Shipley T. Number of products. Arranged 10 to 12, 13 to 15, 16 to 18. Frequency of occurrence. Make sure you can understand what you're seeing in that chart. Why is that frequency 1? I don't see any 1s down here.
Because you only see 10 ones.
Oh. There's only one data point from 10 to 12. What's this 5 here? 19 to 21.
19,
See 19,
1,
21,
2, 3,
and 20.
4, 5. 5 data points from 19 to 20, including 19 and 21. And then you're seeing them all broken down like that. So now we're sorted. Which is nice because we see the min, we see the max. Now remember, you often won't have both of these. You'll have one or the other. We saw the pros of having this. What's a con of this? Can anybody think of a bad thing or something that this creates that we didn't have before? Aaron, what are you thinking?
You lose the exact number of products.
When you had the raw numbers, you knew. All we know now is there are 5 numbers from 19 to 21. How many 19s? We don't know anymore. How many 21s? We don't know anymore. How many 20s? Well, however many 19s and 21s, subtract that from 5, and that's how many 20s. Well, again, that's not exactly how many, it's a relative. So you do lose a little tiny bit of that precision. Although I have a solution for that, we'll talk about that on Tuesday. David, go.
I
think
think
I
I'd say it kind of becomes a little inconsequential depending on how the boss feels between this person making 16 versus 18 products.
That is a contextual difference that we can address if we have more information about the actual situation. This is a great point. This is why I love 243 and 244. We're giving you very basic tools that then you can run and put into your own worlds. So yeah, depending on how the boss feels, maybe it's a big deal though. Maybe these are $10,000 revenue generating items, and 18 versus 17 is a hell of a big deal, right? So, or maybe there's little tiny circuit switches, and this is one of many products these people make, and it's inconsequential. I don't know. I have no idea what the product is we're talking about, so therefore we have to look deeper. But at least we can get the data up if we need it, and then decide which way to do it, right? Mm-hmm. Cool so far? Can we make it even better? I like that. You can do good math on this too. We will on Monday. Or Tuesday. Can we make it even better? What do you think? Think about make it a picture. Think about what Rachel said earlier. You dropped that dot plot in my mind. You got me thinking about dot plots now. Make it a picture. Here you go. Oh, speaking of which, this was called a distribution. You'll hear me use this word an awful lot in this class, so you'll learn it by repetition. If you make it a picture, you get what's called a histogram. A histogram. Yeah. So there's your distribution. I didn't change that. I took the raw data away because it was getting too cluttered on the screen. I didn't like the way it was looking with the raw data too. All this is this picture of the distribution. So you don't lose anything with the picture from the distribution. Any limitations, as Aaron pointed out, the precision limitation is still maintained. Because we still, in this bar that is 5 high, we still don't know how many 16s, how many 17s, how many 18s. We know there's 5 total. So that imprecision is still there. But we do pick up kind of a cool visual thing. What do we pick up? Why is the visual a little bit better than the non-visual, do you think? If you think, some of you might not like this more. Some of you might like the distribution better. But if you like the picture better, Jennifer, what do we pick up?
You pick up what you see the most of.
Ooh, but we can pick that up here too, can't we? 5s are bigger than 2.
Kind of, but visually you see...
5 is now 5 times bigger than 1. Right? Right? We laugh, right, Rachel? But as human beings, we need to see that. We need to see it accurately represented. That the 5 is 5 times bigger. It's a little inane with a small sample or a small population like this. It becomes much more relevant with a large population. What are you going to say, Sandra?
You can. That's what I was going to say. You can see the noticeable difference between the low number and the high number.
Good! And you can see the spread of them. And the fact that there's these gaps, I wonder if they're meaningful. Mm-hmm. We might want to look deeper. This is why my question, should we use an average? I don't know. It's kind of hard to tell from right here. We'll put more on that on Tuesday when we get into which measure of center should we talk about. Good. Any other questions or comments or points? I'd love to hear them if you got them. This is pretty much the only kind of graph I want to focus on today for the remainder of the time we have together. There are lots of others, and they're all great for their own reasons, but for this point in the term, these are like the most relevant right now. So what I want to do next is, I want to tie in, I didn't use Excel to generate all of these, I want to generate some in class with you today. So these are little, if you think of the idea of all the graphical displays that are out there in the world, and then there's a small subset of that that's histograms. Within that subset of histograms, there are also subsets that have other names. They're all histogrammy, but they have different names. So to generate data for this one, it's called a Pareto diagram, or a chart.